Okay, hello everyone, and in this video we'll be talking about the four basic principles of object-oriented programming. We'll be looking at what object-oriented programming is and what are its four basic principles. So let's get right into it. Once again, this video is brought to you by Dynasty Studios, the name of the YouTube channel, and our logo as usual is Understanding is Key. So let's get right into it. What is OOP? You would see the term a lot. OOP, 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 OOP. OOP basically stands for object-oriented programming. It is a programming pattern that uses the concept of objects to organize code. It's a programming paradigm. It's a programming pattern that uses the concept of objects to organize code. Let's proceed. So here are basically the four principles of OOP. Yes, the four basic principles of OOP, and they are the four basic principles of OOP, and they are abstraction, polymorphism, inheritance, and encapsulation. The order of arrangement doesn't matter. It can come, inheritance can come first, polymorphism can come first, abstraction can come last, encapsulation, you can arrange it anywhere. Anyhow, I just arrange it basically like this, so it can easily be understood by you. You can just pick, you can abbreviate here APIE, then you can just call it API. Abstraction, polymorphism, inheritance, and encapsulation. So let's get right into it. Abstraction, this is a process of taking a concept and modeling it as a class. In abstraction, you are taking a concept, an entire concept, and then you are modeling it as a class. Abstraction helps in managing complexity by focusing on the essential aspects of an object or system. Abstraction also allows programmers to create models that can be easily understood and manipulated without knowing the unnecessary details. Let's take that again. This is the process. When you abstract, you are basically partaking in the process of taking a concept and modeling it as a class. Abstraction helps in managing complexity by focusing on the essential aspects of an object or system. Abstraction also allows programmers to create models that can be easily understood and manipulated without knowing the unnecessary details. Let's look at an example of abstraction. An example of abstraction is a drawing application. An abstract class shape could represent the common properties and methods of all classes, of all shapes, draw and move. Concrete subclasses like circle and rectangle would then provide specific implementations for these methods. Let me summarize a bit. What this is basically saying is that an abstract class, you are creating a drawing application. You should have an abstract class. Yes, in C#, an abstract class is a class that cannot be instantiated. You should have an abstract class for shape, and inside the abstract class for shape, you would have already define some set of properties and methods that you expect all shapes to have. Then when you are now inside a circle subclass or a circle derived class, you would now, after you've inherited from the abstract class, you would now tell circle the way you want it to draw. Yes, you would now implement the drawing, you will implement the drawing property of circle, and you implement the movement property of a circle. Do note that when you draw a circle, it's different from when you draw a rectangle. So you will just state draw and move as a property and method inside an abstract class. You won't implement anything there because why? The drawing of circle is different from the drawing of rectangle. It's now inside circle class or rectangle class that you now implement the methods or properties. The next is polymorphism. This allows objects of different types to be treated as objects of the same type. It allows objects of different types to be treated as objects of the same type. Polymorphism happens when an object or method has many forms, but it is all identified by the same name. It happens when an object or method has many forms, but it is identified by the same name. Let's look at an example of polymorphism real quick. Consider a find area method. Polymorphism allows this method to accept different shapes, e.g. circles, rectangles, as parameters, and each single shape class provides its own implementation of the find area method. Again, consider a find area method. Polymorphism allows this method to accept different shapes. You can find area with a circle, pi r squared. You can find area with a rectangle, length times breadth. Finding area with a circle is different from finding area with a rectangle. When you are finding area with a circle, you need three things, which is pi and then r. But finding area for rectangle, you need two things, length and breadth. They are different things. So you are now polymorphism will now allow method. It now allows this our find area method to accept different shapes. You can find area of different shapes. It's to accept different shapes as parameters, and each class provides its own implementation of the find area. The way you find area for circle is different from the way you find area for rectangle. Inheritance. This is a process through which one class shares functionalities, e.g., method property with another class. That's just a simple definition of an inheritance. It's a process through which one class shares functionalities, e.g., it can be properties, it can be method with another class. It's the sharing of properties or sharing of method between two classes. Inheritance is also the process of passing on functionality from a base class to a derived class. It's a process of passing on functionality in the sense of methods, in the sense of properties, in the sense of even fields. You can pass on fields. Yes, inheritance is also the process of passing on functionality from a parent class, a base class, to a derived class. Let's proceed. Let's look at an example of inheritance. One thing to actually notice in this tutorial, what we make use of mostly is C# and ASP.NET. So I will be explaining object-oriented programming by diving deeper into C#. Do not forget that object-oriented programming is general across all object-oriented languages. Yes, we shouldn't forget that. But I will be explaining object-oriented programming deeper with C#. Let's look at an example. C# has single inheritance, which means that a child class, a derived class, can only inherit from a single class. An example of this is animal to mammal to feline to cat. Cat class inherits from feline class. Feline class inherits from mammal class. Mammal class inherits from animal class. It's as simple as that. Don't forget, C# inherits from a single class. C# is single inheritance. And in the example I gave here, cat class inherits from feline class. Feline class also inherits from mammal class. Mammal class also inherits from animal class. From the above, cat can only inherit from one class, which is feline, but it will ultimately inherit all the functionalities of each of the classes above, including mammal and animal, because they have been passed down to feline. Animal is passing its functionalities down to mammal. Mammal is passing its entire functionalities down to feline. Feline is passing its entire functionalities down to cat. So cat will now be an island of functionalities. It will be taken from animal, it will be taken from mammal, and it will be taken from feline. And do not forget, C# is single inheritance, which means you can only inherit from a base class one at a time. Encapsulation, finally, which is my favorite. API, abstraction, polymorphism has been done, inheritance has been done, and now it's encapsulation. This is used to hide the internal state and functionality of an object and allow access to a public set of methods. Permit me to alter this definition by saying you can go further as to explain encapsulation as hiding the internal state and functionality of an object and only allow access through a set of public methods or properties. Yes, you can also define encapsulations like that. You are still right. The object's internal representation and behavior are encapsulated. They are kept inside a capsule. They are prevented from external interference, and access to them is controlled by well-defined interfaces, methods, and properties, actually. And let's look at an example of encapsulation. Imagine a user class with a private _password field. As developers, we wouldn't want to expose that field, making it public. We would make the password private. We would want to provide a public check password method that returns a bool that tells us if an entered password is correct. This check password method, all it's just doing is that it is checking if the supplied password today is equal to the supplied password that I used in creating the account the very first time. It's in your normal day-to-day activity, just like when you are trying to log into your Facebook, you're trying to log into your WhatsApp, and then it's telling you, or the WhatsApp two-step verification code, and it's telling you that you provided different passwords to it. You can implement something like this. So check password method. This means the sensitive information in the _password field is never revealed. I'll take that example again. Imagine we have a private password field. And as developers, we wouldn't want to expose that field because a password is a private thing. Making it public, that is using the public access modifier, we wouldn't want to expose that field by making it public, i.e. using the public access modifier. So we would want to provide a public check password method that returns a bool that tells us if an entered password is correct. outside the class, I can only determine if a provided password is correct by using the check password method. This means the sensitive information stored in the password field is never exposed. If you want more on private and public fields, you can check out my video on access modifiers. So finally, by adhering to these 4 principles, object-oriented programming provides a powerful and flexible framework for designing and organizing code, making it easier to understand, maintain, and extend. While the core principles of object-oriented programming are consistent, the implementation details can vary based on the features and syntax of each programming language. A great example is C# and C++ implement OOP, but they do so in different ways. Yet they both adhere to the fundamental principles. The fundamentals of object-oriented programming, which is abstraction, polymorphism, inheritance, and encapsulation, it's common to all languages that are object-oriented, but the way you implement them differs. The way you implement them might be different because a C++ syntax is different from a C# syntax, but they are both using API under the hood, each and every single one of them. Therefore, a developer familiar with object-oriented concepts or object-oriented programming concepts can transition to different languages and apply those principles effectively, showcasing the language independent nature of object-oriented programming. Object-oriented programming is independent of any specific language. Okay, next. So finally, I guess we're done. This video was about a recap of the video. We talked about object-oriented programming, and then we talked about the 4 principles of object-oriented programming, which is API, abstraction, polymorphism, inheritance, and encapsulation. So thank you very much for sticking to the end. And then I gave examples. Yeah, I gave examples. You can look at those examples, read those examples over and over again to get a clear picture of what we're trying to say. Thanks for sticking around to the end. You're a legend. My name is Dynasty. Yes, I am your tutor for this video. And see you in the next. Stay tuned and happy learning. Thank you very much. Thank you very much.